Okay, here we go, short topic. Here's an interesting kind of little word problem. This is the kind of thing you could easily give this to like a smart, fourth grader or something like that. Let's do it. There's this person, okay, I'm calling them Mr. H, doesn't really matter what their name is, and they go on a trip, a round trip. So we start at point A, some city, and some other city or town, B. And we go from A to B and then back again. And the issue is that on the way there, we travel at 40 miles per hour, maybe because there was a lot of traffic, but on the way back, now it's kind of late at night, and we do the trip back in much faster, 60 miles per hour. Okay, question: what is the average speed for the entire round trip? All right, it's a little bit of a trap. If you go 40 miles per hour on the way there and 60 miles per hour on the way back, then you're tempted to just average them and say, well, overall, the trip was, then you must have been going 50 miles per hour, kind of on average. But that is not quite right, because, and this is the subtlety, so there is some fixed distance between A and B, and by the way, I don't know what it is, and the problem doesn't give it either, so that is maybe suspicious, or perhaps leading to the idea that it's irrelevant to solve the problem, which maybe is intuitive, right? If the distance were double, this shouldn't change. Anyway, I have some sort of fixed distance to travel from A to B. Well, it's not just 50 miles per hour, because since it takes me longer to get there than it does to get back, then I spend more time going 40 miles per hour than I spend going 60 miles per hour. So intuitively, the answer should be something less than 50, because the 40 mile per hour time is dragging us down, because I spend longer going 40 than I do going 60. Okay, let's do the problem. This is a good opportunity to, review, basic kind of middle school word problem strategies. Like first asking yourself, hey, what am I trying to actually calculate again? I'm trying to calculate average speed. Okay, it goes without saying that it's much better to do this live. I give you a few minutes to think about it and talk about it in groups. And okay, so it's very sad to be doing this via video. So I don't know, maybe try to figure it out yourself. Pause the video for a minute and try to do it. But okay, a good place to start is even just saying, what is average speed? What does average speed even mean? Well, it's just the total distance divided by the total time. And okay, the only sort of physics required for this problem is that distance equals rate times time. That's just what a rate is. A rate is just distance over time. It's the amount of distance you travel in a certain time interval. That's called the rate. Okay, well, if that's the case, then I think I know what to do now, because actually, what is the total distance? Well, just temporarily letting the distance between these two cities be d, I go there and I go back again, so the total distance is 2d. What's the total time? Well, what is the time spent going there? Well, if distance equals rate times time, then you can just as well write time as distance over rate. And so the time it takes to get there is going to be d over 40, because I have d miles to travel, and it takes me, it's going to take me d over 40 hours to do that in. Okay, and then finishing this off, how much time does it take to get back? Time is just distance over rate, so again, it's d over 60. Okay, so the d's cancel, which is what we were thinking would happen anyway, and the sort of answer to this problem is, 2 over 1/40th plus 1/60th. Okay, and we can calculate, what that is, but that's kind of the big answer. Okay, what is it actually? Maybe I want to I don't know, divide by 2 or something, so that's 1 over 1/20th plus 1/30th, just to keep the numbers small. And now what? I guess I want like 60 down. I think this is making this harder than it needs to be, but if I multiply this by 3 over 3, so I get 3 plus 2 over 60. I think I did that right. Multiply this one by 2 over 2 and this one by 3 over 3. So this is in fact just 60 over 5. So, something went wrong. What did I do? 2 over 2 over, sorry, I made some horrific error. I think it was here that I made the horrific error. If I divide this by 2, it doesn't become 1/20th over 1/30th. It actually just gets worse, right? Because if I divide this by 2, that's like 1/80th over 1 over 120. Yeah, so actually, okay, let me stop trying to be cute and cool and just do the problem the most boring way. What's the common denominator of 40 and 60? It's going to be 120. So 1 over 40 is 3 over 120, and 1 over 60 is 2 over 120. So there we go. It's going to be then 240 over 5. And that is 48. So the answer to this problem is 48 miles per hour. Okay, good. What does this have to do with anything? Well, I shall now introduce to you this thing called a harmonic sequence. Okay, what is a harmonic sequence? Well, we've seen already arithmetic sequences and geometric sequences. So what is a harmonic sequence? Okay, well, I'll tell you. A harmonic sequence is answer is, I'll just write it right now. It's a sequence whose reciprocals form an arithmetic sequence. Reciprocals form an arithmetic sequence. Okay, great. So, for example, just to sort of reiterate the definition in algebra, if you give me some sequence A1, A2, A3, etc., this is harmonic, if and only if 1 over A1, 1 over A2, 1 over A3, etc. is arithmetic. Okay. So it's a sequence, all of whose terms are reciprocals of an arithmetic sequence. Okay. Good. Well, let's just kind of do a quick problem now, just to make sure we get it. So here I will give you, take the following harmonic sequence. So I'm now telling you it's harmonic. Take harmonic sequence that goes like this: 5/8, 5/3, 10/11, 5/8, etc. And the problem is find a sub 8. Okay, so find the 8th term of the harmonic sequence which begins 5/3, 10/11, 5/8, etc. Okay, so once again, I usually give a couple minutes in class for you to work this out, but I don't think it's that hard because, well, we just can do it, right? What is the definition of what it means for the sequence to be harmonic? Well, it means that I know that 3/5, 11/10, 8/5, that sequence is arithmetic. And I can just easily reason about this sequence. That's really 6/5. So I seem to be adding 1/2 here. And is that true? Yeah, it is. Because that would be another 5/10, would be 16/10, which is 8/5, etc. Okay, so perhaps this sequence could be called the B's. And so what I have is that B1, this is the organized way to do it, B1 is 3/5, the first term, and D, the common difference here, is 1/2. So I just have a very straightforward way of calculating the 8th term of the B sequence, answer is it's 3/5 plus 7 of these 1/2. So what is that? That's going to be 6/10 and 35/10. So that's 4. What happened? Yeah, multiplied by 2. So yeah, 6 plus 35/10. So 41/10. I seem to vaguely recall some kind of different answer, but anyway, that just must be it, unless I'm making a horrible mistake. Yeah, 7/2, 5 times 5, 35/10, and 6/10. So that's 41/10. Okay, so if the 8th term of this arithmetic sequence is 41/10, then it must be that the 8th term of the harmonic sequence is 10 over 41. Okay, great. Great. So sort of that's it, and you might think sort of who cares? Okay. Well, sure. Sure. Okay. So let's just sort of pivot from this immediately to a conversation about means. Means are kind of averages, and well, you've seen some means already. I think this came up in the packet, or it's about to. There's this thing called the arithmetic mean. What is the arithmetic mean? Well, it's the average of two. Well, I'll just tell you. If given an arithmetic sequence, A blank B, then the arithmetic mean of two numbers, A and B, is the number in between those two numbers in an arithmetic sequence. Okay, so x is the arithmetic mean of A and B if A, x, B is in an arithmetic progression. Okay, and of course, we can just calculate this, right? Because I have to add some constant every time, so I'll just say, plus D or whatever. Or maybe I don't even need that. Maybe I just go straight for the definition of an arithmetic sequence. What's the definition of an arithmetic sequence? Well, it has the same difference. So the difference between the second term, x, and the first term, a, is the same as the difference between b and x. And then I can just solve for x, right? So I get 2x equals a plus b, and indeed x is just a plus b over 2. Okay, so I think I sort of knew that already, right? So just to summarize, the arithmetic mean of two numbers a and b is a plus b over 2, and you can just confirm that, yeah, what is even d then, I guess? You have, well, it's b minus a over 2, I guess, right? Yeah. So then you add that twice. Okay, great. That's just what we call, since middle school or something, or even earlier, that's just what we call the average. But really, that's just one way of averaging two numbers. It's the way of averaging that assumes sort of arithmetic growth, from A to B. But there's another way of doing it, the so-called geometric mean. And I think you've seen this in middle school in geometry. What is the geometric mean of two numbers? Well, it's the number between them in a geometric sequence. So, okay, let's go. What does it mean if this sequence is geometric? If this sequence is geometric, then it means that the ratio between a term and the previous term is the same. So x over a, the ratio between x and a is the same as the ratio between b and x. And thus, we conclude that x squared equals ab, and so x is like root ab. Okay, that's kind of exciting. That means that the geometric mean of two numbers, let's assume they're positive and everything like that, is root AB. And I guess the common ratio now would be like root B over A or something like that. Okay, so this is another kind of average. It's the average between two numbers if they're growing geometrically. Okay, that's so unreasonable, right? Suppose you have some sort of geometric growth, you have some kind of doubling thing that's going on. So, on the first week you have 2 frogs in your pond, but by week 10 you have like 1,024 frogs in your pond. So it's growing, it's doubling every week. I think I did that correctly. Or maybe not. Maybe, what did I say, 2 frogs, then 1,024? Yeah, I think I did that right. After 10 weeks. So, okay, you might say, okay, well, what about week 6? No, I'm all off. So sorry, let me take it back. 11 weeks. Jeez. Week 1, I'll just keep on going. Week 1, there are 2 frogs, and 10 weeks later, so that's week 11, there are 2,048 frogs. So there's been an increase by a factor of 2 to the 10. There have been 10 doublings. Okay, so there are 2048 frogs at the end, there are 2 frogs at the beginning. Then you might ask, okay, well, how many frogs, how about at the halfway point? What's the average of 2 and 2048? Well, you wouldn't want to take the arithmetic average then, because the average of 2 and 48 sort of is respecting the idea that, you know, this is growing geometrically. So you would be asking really like how many frogs were there on at week 6, halfway in this frog growth. And the answer is at week 6, if I'm doing this all in my head, I think I get that there are 64 frogs. So 64 is the average of 2 and 2,048 in a certain sense, assuming the growth is happening that way. Okay, that was a long-winded ramble. Last one, where's this going? Well, I can also ask for the harmonic mean. What does the harmonic mean? Well, it's just the same thing, right? Here I have 2 numbers, A and B, and I'm asking for the number in between A and B such that A, X, B form a harmonic sequence. And, okay, well, what is the definition of harmonic? What does it mean if the sequence is harmonic? Well, if the sequence is harmonic, then 1 over A, 1 over X, 1 over B is arithmetic. Okay, and if this is arithmetic, as we've already seen, then it must be true that 1 over X is the arithmetic mean of 1 over A and 1 over B. So it's 1 over A plus 1 over B over 2. And then what is therefore X? X is 1 over A plus 1 over B over 2. In other words, the harmonic, so this is, maybe I should write this, that's X. But what was X? It was the harmonic mean of A and B. Answer, the harmonic mean of 2 numbers is the reciprocal of, it's the reciprocal of the arithmetic mean of the reciprocals. Okay, so this is another way of averaging 2 numbers. And when does this come up? Well, you might have noticed that I've been sort of avoiding erasing the left-hand side of the board, and that's because this just came up in this word problem. So, if you have, that's exactly what this is right here. Boom. This 2 divided by 1 over 40th plus 1 over 60th can be, of course, re-expressed as 1 over 1/40th plus 1/60th over 2. Or I could just simplify my answer over there a little bit more. But anyway, the solution to this problem, in general, the solution to what is the average speed of a round trip, in terms of the speeds on the way there and the way back, the answer is going to be the harmonic mean of those 2 numbers. So 48 is the harmonic mean of 40 and 60. It's the average of 40 and 60 in this kind of particular sense. And harmonic means come up with sort of rate problems. It's often true that the harmonic mean of 2 numbers, if those numbers are rates. Okay, that I think is quite exciting. I would say the average person, you should just maybe turn off this video now. But for those who are interested, there is another application of these means. Let's see, I think we know this well enough now that we can just erase it. So I'll just give you one sort of extra kind of bonus curiosity, which is you can think about these means geometrically. So take some rectangle, and let's let the size of the rectangle be let it be an A by B rectangle. Okay, great. interpret geometrically the various means of A and B as sort of ways of averaging the rectangle or something like that. What's one way to kind of average the rectangle? Well, let's consider the arithmetic mean. We can kind of average the rectangle by forcing it to be a square. And well, okay, so I have some sort of square, and what sort of property is preserved? I'm kind of saying this in sort of a weird way, but what property does the square have whose side length is the arithmetic mean? Well, it's just the square whose has the same total perimeter as our rectangle. Okay, so I said that a little bit awkwardly, but let me try to kind of rephrase. To the extent that turning a rectangle into a square is a kind of averaging procedure, then you can think of the arithmetic mean as kind of caring about the perimeter. So construct a square with the same perimeter as this rectangle. Well, the total perimeter would be 2a plus 2b, and if you divide that by 4, you get a plus b over 2. Therefore, we can interpret the arithmetic mean sort of geometrically as giving you, well, I'm just repeating myself now, giving you the side length of a square with the same perimeter as a given rectangle. Okay, continuing this discussion, what is the geometric mean? What can we say about it? Well, the geometric mean kind of conserves area. So the area of this rectangle is, of course, a times b. So what can I say about a square with the same area as this one? Well, what will the side lengths of that square be? Well, they'll be root AB. So take a square whose side length is root AB, then the area of that square will be AB. In other words, think of the geometric mean of two numbers as creating from the rectangle of those two numbers a new rectangle which preserves area, whereas this preserved perimeter. Okay, and what does the harmonic mean do? Harmonic mean. Okay, I think this one is more difficult to see, but the answer is it preserves. Now I forget. Preserves perimeter to area ratio or something like that. Let's see if or I might have that backwards. Let this be k. Let this be a square with side length k. What is the perimeter to area ratio? I can't remember which it is, but I think it's, well, let's just try it. So perimeter to area ratio of our rectangle. Answer, the total perimeter is 2. I guess it's going to be the other one. It's going to be area to perimeter. I'm really not sure about this, but let's just find out. Area to perimeter. I guess we can always just switch it if we're done. So the area is, of course, AB, and the perimeter is 2A plus 2B. And yeah, here it is, right? It's because now this just is the harmonic mean in disguise. Divide through by AB. If you divide through by AB, you're going to get 1, I think. You're going to get 1 over, if you divide the top by AB, you get 1. You divide the bottom by AB, you're going to get 2 over B plus 2 over A. But that's not exactly what I was hoping for. Oh, okay, so that's the area to the perimeter ratio of a generic rectangle. Then, well, let's just jump to the end. What is K? K is the harmonic mean. So yeah, I think I got this right, because thus every side of this square will be 1 over A plus 1 over B over 2. And Therefore, what is the area to perimeter ratio in this square, well, the area is going to be, perhaps it's useful in this time to simplify this a little bit. Because what is 1 over A plus 1 over B over 2? Well, for starters, I can multiply the top and bottom by 2, and we've already seen that it can look like that. But then I might also want to get a common denominator down here, so that's 2 over A plus B over AB. And so perhaps a more convenient way, or just an alternative way or something, of talking about the harmonic mean is that it's this. And, okay, so the area of this thing is going to be that squared. So it's going to be 2AB over A plus B. Quantity squared is the area. And what's the perimeter? The perimeter is going to be the sum of 2 of these. No, 4 of these. So it's going to be 4 times 2AB over A plus B. And, alright, what happens when you do all that out? Gosh, what do we get? We get 4A squared B squared over A plus B squared all over 8AB over A plus B. And now, if we do a bunch of cancellation properly, let's see, I'm left with an A, B up top, and a 2A plus B on the bottom. And is that the same thing I get here? I think it is. Because now, once again, I multiply by A over A and B over B, so that becomes 2A plus B over AB. Okay, so I made sort of maybe awkward algebra moves, but perhaps now you could just sort of run this whole argument back again. I claim that the square, these are all squares, whose side length is the harmonic mean, has the following property relative to the original rectangle. And that is that if you compute the area to perimeter ratio of the original rectangle, you get AB over 2A plus 2B, and actually it's sort of stupid that I went backwards. Maybe just don't even do any of that, because there it is right there. That is just a simple calculation. It's the area over the perimeter. But the area over the perimeter for the square, whose side length is the harmonic mean, is also just the same thing. Okay, and there's even one more mean. There's the quadratic mean. Actually, there are many means, but the quadratic mean is the well, I'll tell you what it is. It's root A squared plus B squared. I think I'm doing that right. So what is the quadratic mean? How can we interpret it geometrically? It's a square whose diagonal is it's a square whose diagonal, something went wrong. I want to say it's the square whose diagonal has the same length as the diagonal of our original rectangle, but no, that's not right. So maybe I just have my formula for quadratic mean wrong. So the diagonal of a rectangle of side length AB is of course going to be root A squared plus B squared. So then if this is root A squared plus B squared, then what kind of square has that as its diagonal? I guess it's going to be root A squared plus B squared over 2. I think that's just right. Because when you square and add those together, yeah, that's right. So I guess the quadratic mean, I've just forgotten what the quadratic mean is, but unless I'm making a horrific error, I think the quadratic mean of two numbers is root A squared plus B squared over 2. I hope that's right. And you can interpret that geometrically as given some rectangle of side length AB, it's the square whose diagonal is the same length. So this sort of preserves diagonal length, this preserves area to perimeter ratio, this preserves area, and this preserves perimeter. So each of the means has this kind of interpretation. Okay, goodbye.